In this video, we will walk through an example to show how to build an AVL tree with a concrete input. This is the input. The first number is 28. To begin with, we have an empty tree, hence 28 will be colored black. And then the second number is 2. This node will be colored red, and we use binary search tree insertion to place 2 under 28 as a left child. The next number is 3. 3 is going to be the right child of 2 because 3 is less than 28 and greater than 2. We have a red-red conflict. We look at its uncle. So the uncle is black. So what we do here is we move X up here, and then we will do a left rotation. We get 28, 3, and 2. And this is a new X. This is black. It's black, 28. And then this time we are going to recolor 3 to black and 28 to red. And then we are going to do a right rotation on 28. And then we are done. This is a red-black tree. Next, we have 12. In this situation, we get 12 here. 12 is the left child of 28. And look at his uncle. The uncle is red, so this is an easy case. We just need to recolor 28 to black and 3 to red. And then we move the new node up to the root. Since this is already the root of the tree, we simply color 3 black. Then that is done. So this is a red tree. The next number is 27. Using binary search tree insertion, 27 becomes the right child of 12. This time we get a red situation. Then we look at its uncle. Uncle is black. So this is similar to what we saw earlier. What we do is we move new to its parent, and then we do a left rotation. So for this particular subtree, after the rotation, what we get here is 27, and then 12, and then 28. Okay, in this case, what we do here is that we are going to recolor 27 from red to black, like this, and recolor 28 from black to red, like this. And then we do a right rotation. And after the right rotation, we get to this, and that is done. This is red-black tree. The next number is 6. According to binary search tree insertion, 6 is inserted under 12 as a left child, and we now have a red conflict. And so we look at the uncle of 6, which is red, and this is an easy case. We just need to recolor 12 and 28 from red to black, and recolor 27 to red, and then move X up. And that becomes this. And since the parent of 27 is black already, this is done. This is done. So this is a red-black tree. The next number is 26. So according to binary search tree insertion, 26 is inserted as a right child of 24, and we have a red conflict. We look at its uncle. We look at 26 uncle, which is a 6, which is red, and this is again easy case. We color 6 and 24 from red to black, and the grandparent of 26 from black to red. And then move this new to 12. This is after the recoloring. This subtree is red-black, but there is another red-red conflict. Now we look at its uncle. Uncle is black. And in this case, we will first need to move this new up here. Move the new up here, and then do a right rotation. We get, and this is the root. The root is 3, which is so 27's grandparent is 3, which is black. So this is 3. And now we need to recolor 12 from red to black, and recolor 3 from black to red, and then we do a left rotation. And that's in this part. Look at this. After that, this is what we have, and this is done. This is a red-black tree. From now on, we are going to remove these square blacks to save space. Okay, so then this becomes there. So now next number we have is 22. According to binary search insertion, 22 is inserted here, which is the left child of 24. And in this case, look at its parent. The parent is black. There is no conflict. This is red-black tree. So this is the red-black tree. The next number is 10. According to binary search tree insertion, 10 is inserted here. There is no conflict. The next number is 9. 9 is inserted here. There is conflict. And then we look at its uncle. Now remember, its uncle here is black, even though we didn't write it down. So it's black. So this is the case where we need to move X up to 10 and then do a right rotation like this. Okay, after that, we need to do another rotation. We get this. After that, we're going to recolor 9 from red to black and the grandparent of 10, the new X, from black to red, and then we do a left rotation. Then we get this. There is no conflict, so this is done. This is our dt. The next number is 20. According to binary search tree insertion, 20 is now the left child of 22, and there is a red-red conflict. We look at the uncle of 20, which is 26. It's red. Then it's straightforward. So we just need to recolor 22 and 26 from red to black. Recolor 20's grandparent from black to red. And we get to this subtree. This subtree has the same black height, but then we have another conflict, red conflict, and then we look at its 24's uncle, which is red. So in this case, we just need to recolor 3 and 27 from red to black, and 12 from black to red. But then since 12 is already the root, so in the end, we are going to color 12 as black. So this is done. This is red, black tree. That is the end of this video. Thank you for watching.